Welcome to Math 2610, Section 0. This section is not really from the book, it's some of the background that you should have seen through high school or through other classes to prepare you for this class. So we're going to quickly review a simple system of linear equations. Okay, so what is a system of linear equations? This is what we're going to be dealing with throughout this entire course, is systems of linear equations. Here is an example of a system of two linear equations. You can see we have two equations here. We're normally going to be dealing in this course with much larger systems, with more variables, with more equations, but this is a system of two linear equations. Here are a couple of items to point out on here. The A's on here and the B's, when you see a system of linear equations, normally these will be numbers. And we call these things the coefficients. So the numbers associated with the variables are called coefficients. The C's, the numbers are numbers, they're on the right-hand side, and these are generally called constants. So the coefficients are on the left-hand side, the constants on the right-hand side generally. Sometimes you have to rewrite things a little bit. The X's here, when you see a system of linear equations, these are going to be variables. So x1, x2, or x, y, z, so forth, we call them variables. And the idea is that these are the things that you have to change, where you have to find a number that works given all of the other numbers in the system. We have to find something where the left-hand side of every equation is the same as the right-hand side of every equation. That's what we call solving a system of linear equations. So solving a system of linear equations means that we are trying to find values for the variables that satisfy, in this case, both equations, or with larger systems that satisfy all of the equations. A single number for each variable that satisfies all of the equations that you've been given. Here's a system of two linear equations, an example. 2x1 plus 3x2 equals 11, negative 2x1 plus 2x2 equals minus 6. And we're going to see three ways of solving this simple system of linear equations: an elimination method, a substitution method, and a graphical method. And these are things that you should have seen in previous classes or in high school coming into this course. So first off, elimination method. Here we start adding and subtracting things, multiplying equations to try to eliminate some of our variables. So for instance, we're going to take our two variables and we're going to note that if we just add the two equations together, we can right away eliminate a variable. So 2x1 plus negative 2x1 gives me 0. Add the x2's together. 3x2 plus 2x2 is 5x2. That equals 11 minus 6. That equals 5. So I end up with 5x2 equals 5. I've gotten rid of one of my variables. I've eliminated it. I can divide, and that gives me x2 equals 1. So I've solved for one of my variables. What about my second variable? Well, I can do the same thing with the extra added step of doing a multiplication, of multiplying an entire equation by a number. Here, when we look up above here, we had a very nice thing going on where we noted that if we just add them together, something's going to disappear right away. Well, that usually doesn't happen, so we have to multiply some things out first. So this time we're going to try to get rid of the x2's on here. So we have to try get the same number in front of them, or as above, a negative of one of the numbers in front of them. So what I'm going to do is note that if I take this equation, multiply it by 2, what am I going to get? Multiply the entire thing by 2. Well, we get 4x1 plus 6x2 plus 20 equals 22. And if I take this one, multiply the entire thing by 3, I'm going to get minus 6x1 plus 6x2 equals minus 18. So I've now gotten the same number in front of the x2's. So now I can take care of them by subtracting one from the other. I am going to subtract. What do I get? 4 minus negative 6. 4 minus minus 6 gives me 10 x1 plus 6x2 minus 6x2 gives me 0x2. 22 minus negative 18. Again, subtracting a negative number, change it into a plus. So that becomes 22 plus 18 equals 40. What do I have here? I have that 10x1 equals 40. And x1, when we divide through, equals 4. And there is a solution. So if I have x1 equals 4, x2 equals 1, and I put it into each of these equations, I am going to solve both the equations. It's going to work for both the equations. That's my goal, to find the values for the variables that satisfy both of the equations. So that was the elimination method, where you're taking entire equations, adding them together, sometimes multiply them by a number to get rid of an entire variable. Substitution method. The substitution method is where we take one equation, change it around a little bit so we have a variable equals something, and we plug it into the other one. So we're going to express one equation in terms of a single variable. I am going to choose this one just because it's going to be the most convenient. So I take that one. What do I have? I have minus 2x1 plus 2x2 equals minus 6. I am going to rearrange this thing to get x2 equals something. Now you could do it where you get x1 equals something. You can take the first one. It doesn't matter. You're going to come out with the same answer every way. So I'm going to rearrange this. This is equal to 2x2 equals negative 6 plus 2x1, because I take the negative 2x1, move it to the other side. Divide everything through by 2. I have x2 equals negative 3 plus x1. There is my equation written in terms of a variable. So now I take my second step, substitute that equation into the second equation. So what's my second equation? 2x1 plus 3x2 equals 11. Now I know what x2 is equal to, so I plug it in for there. So I get 2x1 plus 3 times, what's x2 equal to? Minus 3 plus x1 equals 11. Solve it out, simplify it. 2x1 minus 9 plus 3x1 equals 11. And now I can take this and I can simplify it, gather the like terms together. So take the x1s together. I get 5x1 equals, take the 9 over to the other side, the minus 9. So that equals 20. I have x1 equals 4. I've solved for my first one. And now I missed the third step, which is to substitute back into the first equation. So I know what my x1 is equal to. I have my first equation that x2 is equal to minus 3 plus x1. So x2 is equal to minus 3 plus, substitute back the value of x1 plus 4. So that equals 1. x2 equals 1. And you'll note it's the same exact solution as before. So that's the elimination method and the substitution method. The third method to kind of be familiar with is the graphical method. And that's where you draw out these lines and see where they intersect. So here, we want to make the graphical method. So we are going to draw the two lines on here. Let's take our first equation. And we're going to note on here, well, okay, what if I let my x1 equal to 0? So we have 2x1 plus 3x2 equals 11. This is my x1 axis. This is my x2 axis. So if x1 equals 0, that tells me that 3x2 equals 11 and x2 equals 11 over 3. Not very pretty, but that's like 3 2/3. So I'm just going to put a little bit of a scale on here. Let's say that this is, that's kind of 6 up there, -6, -6, and 6. And I'm going to draw it on here. So I know that this line goes through x1 equals x1 0, and x2 is 3 2/3, which is about here. So that's the point, 0, 11 over 3. Now, if I let x2 equal 0, what do we get? When x2 equals 0, I get 2x1 equals 11. So x1 equals 11 over 2, or 5.5. So x2 is 0, x1 is 11 over 2. We have that point right there, which is 11 over 2, 0. And we have our first line, which runs through there. There's our first line. Now, repeat for the second line. So we're going to take our second equation now, minus 2x1 plus 2x2 equals -6. Let x1 equals 0. We're going to get 2x2 equals -6, or x2 equals -3. So 0, -3 is a point. And then we're going to say that x2 equals 0. What do we get? That tells us that minus 2x2 equals -6. Sorry, minus 2x1 equals -6, or x1 equals 3. So 3, 0 is a point. Right about there. And those two things give me my second line. I kind of look at this and say, where is the intersection? Intersection is right there. Read off on the chart where it is. That point is 4 and 1. So x1 equals 4 and x2 equals 1. Now this is the least accurate method of solving it. But it does have its place where sometimes you can sketch it out and get an idea of where it is, but then you would almost always go back to one of your other methods, either your elimination or your substitution method to get the actual results, or one of the methods that we are going to see in this course. So in this course, what we are going to be doing is solving systems of linear equations. Here's a couple more examples where we can have some other things that are happening. So we saw one system that gave us an answer. What if we have something like this? Well, let's take this example, and we can note right away that if we add these together, we eliminate a variable. So what happens here if we just add these two equations together? We get 0x1 plus 0x2 equals 5. Uh-oh, 0 equals 5. There's a problem. That's impossible. That is no solution. And we are going to see that when this happens, that you can very easily have two equations that do not have a solution, or multiple equations that do not have a solution. We're going to see that we call those inconsistent. And if you were to take these and graph these out on a graph, you would get one line that looks kind of like this. You would get a second line that looks like this. They would be parallel, they would never meet. So that is no solution. The two lines just never meet. Here's another example. We take this one, we can note, oh, right away, if we add them together, go back to that old standby. What do we get? 0x1 plus 0x2 equals 0. What? 0 equals 0? Well, that's telling us that the equations are okay to add together, but we aren't isolating any variables. So that's the problem. In this case, take a closer look at these equations. You'll note if you take that equation multiplied by -1, all you do is you get that equation back. They're the same thing. So you're trying to solve for two different things, but they're the same thing. If we were to take these and draw these out, what do we get? Well, our first equation looks like this. Our first line looks like this. Our second line looks like that, directly on top of it. So what that means is that we have infinitely many solutions. Any point on that line is a solution. Okay? So that is another type of system of linear equations. And here are the couple of definitions. A system of linear equations, in this case I gave you system of two equations with two variables. We're going to get more into larger systems of equations. If there is at least one solution, it's consistent. We call it consistent. If there is no solution, as we saw in the second example, we call it inconsistent. And we are also going to see, or we saw three examples. We saw an example where there was a single solution. We saw an example where there was no solution. We saw an example where there were infinitely many solutions. We are going to see that those are the only three possibilities. This is one of the key things that we are going to learn in this course and to try to understand. That any system of linear equations, no matter how many variables, how many coefficients, how many equations we have, if it's consistent, in other words, if there is at least one solution, there is exactly one or infinitely many solutions. You are never going to get into an instance with linear equations where you have 5 solutions and only 5 solutions. Can't happen. This is going to be one of the key things that we are going to see in this course. So just to summarize, this is a quick review of a couple of techniques that you should understand going into this course. You should know how to solve systems of linear equations, small systems of linear equations, using substitution, using elimination, or using a graphical method. You should have a bit of an understanding of how to find a single solution, and have a bit of an idea that sometimes there is no solution, sometimes there are infinitely many solutions. All right, thank you for today, and in the next class we will start looking at chapter 1 in the textbook.